Introduction to Probability and Significance Testing. Probability is a fundamental concept in statistics. It measures the likelihood of an event occurring. Significance testing helps determine whether an observed result is statistically significant or due to chance. Understanding probability. Probability is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. For instance, the probability of rolling a 3 on a 6-sided die is 1/6, as there is one favorable outcome, rolling a 3, out of 6 possible outcomes. Coin toss. A coin toss has 2 possible outcomes, heads or tails, with a probability of 1/2 for each. Card draw. Drawing a specific card from a deck of 52 cards has a probability of 1/52nd, as there is one favorable outcome, the specific card, out of 52 possible outcomes. Real-world examples of probability. Probability plays a crucial role in various fields, including medicine, weather forecasting, and gambling. Weather forecast. Weather forecasts use probability to predict the likelihood of rain, snow, or other weather events. Medical research. Clinical trials rely on probability to determine the effectiveness of new treatments and medications. Gambling. Probability governs the odds of winning in games of chance, like lottery, roulette, and poker. The essence of significance testing. Significance testing is a statistical method used to determine whether an observed result is statistically significant or due to random chance. Research hypothesis. This is the statement that the researcher wants to test. Null hypothesis. This is the statement that there is no effect or relationship between the variables. Statistical significance. This refers to the probability of observing the results if the null hypothesis is true. Error level. This is the probability of rejecting the null hypothesis when it is actually true. Steps in significance testing. Significance testing involves a series of steps to evaluate the significance of the observed results. State the research hypothesis. Define the hypothesis you aim to test. State the null hypothesis. Define the opposite of the research hypothesis. Select an error level. Determine the acceptable probability of making a type 1 error. Select and compute the test. Choose the appropriate statistical test and perform the calculations. Interpret the results. Analyze the results and draw conclusions about the research hypothesis.